talk about writing negation statements, and then from that, we'll learn how to write the inverse and the contrapositive of a conditional. At the end, we'll learn the 3 steps of an indirect proof. Okay. What is a negation? You change the truth value of a statement. Best to use not, the word not. You should copy that down when we talk. The inverse, the inverse negates a hypothesis and the conclusion of a condition. I really thought I really thought I had an example for this negations. Whoa, let's undo that. Get a marker out. So let's talk about the light switch. Or the light. Let's say we want to negate the statement the light is on. Okay? And so what would the negation be? It changes the truth value of the statement. Okay? So how could you negate my statement? If I say the light is on, how could you negate that?
The light is not on.
The light is not on. Okay? A lot of people would say the light is off. And that works out okay as long as there's one clear-cut on-off situation. There's no in between. Okay? If we had a brownout and the light was half on, or if we had a dimmer switch and it was only a tiny bit on, you'd have to have a clear line if you're going to choose to go off, the word off. Okay? If I said Silas is late, then your negation of that would be Silas is not late. Okay? We'll determine that as soon as I read that little green note. Alright? So negation means you change it. And usually it's best to use not. Okay? Now the inverse negates the hypothesis and the conclusion of a conditional. So if this is my conditional, if the switch is up, then the light is on. If the switch is up, then the light is on. If I want to write the negation of that, the negation of that. If the switch is up, then the light is on. In this room, that's a true statement. You turn the switch up, the light comes on. Do you have any rooms in your house that's not true for? Amber does? Brooke does? Only those 2, 3? Okay. What happens is if you have a room like this with a door here and a switch, and you've got a door over here and a switch, quite often those switches are both hooked to the same light, and so sometimes you'll turn it up to turn it on, sometimes you'll turn it down to turn it on, right? Another scenario is a hallway, a stairway, things like that, where you've got multiple switches to the same light. They won't always be up to be on, but in this room, that's a true statement. Okay? So if I want to write the negation of that, remind ourselves what, I'm sorry. I want to write the inverse of that, sorry. I want to write the inverse of this. If the switch is up, then the light is on. What would the inverse be? I'm sorry, I misled you there. How would I write the inverse? What did the statement for inverse say? Negates hypothesis and the conclusion of a conditional. So I need to negate the hypothesis and the conclusion. If I negate the hypothesis, Emily, what would it say? Which part of this statement is the hypothesis? Let's make sure we're all talking about the same thing. If, okay, so we say the switch is up, right? That's the hypothesis. There you go. So you'd say if the switch is not up, negate the conclusion now. Silas, I know you just walked in, but you get the feel of this already?
Yeah, so then the light would be off.
Okay. As long as, you missed this conversation, but as long as there's a clear line between on and off for this scenario, like for a light, there's no partly on or partly off, there's no dimmer switch, or there's no brownout going on, was the examples we used, then that works out okay. But it's almost always better, so that you don't avoid those scenarios, that we would say then the light is not on. And I agree with you. In this scenario, off would be an appropriate use of, an appropriate way to write that, okay? But I think it's best if you just get in the habit of using not, okay? Okay, there's not really a storm coming today that I'm aware of, so don't get too excited. Says, if tomorrow's storm drops 10 inches of snow, then we will not have school. Okay, so inverse. Let's just avoid arguing. Let's say that we say this is a true statement. Probably in 28 years I've been coming into this building, we've never had 10 inches of snow dropped in one night and had school the next day. So I would say that's a true statement. What's the inverse of this say? Megan, you ready? If
we do not have school tomorrow.
sounds like you're writing converse.
Inverse. If tomorrow's storm does not drop 10 inches,
And
we will have school.
we will have school. Good. You took the word not out of it this time. Then we will have school. Okay. Is that a true statement?
No.
Could be, could not be. What if it drops 9.5 inches? Is that 10? No. You think we'll have school? Probably not. What if it drops 16 inches? Is that 10 inches? So if it drops 16, that's not 10, right? Would we have school tomorrow? No. Okay, so this is not true. And so you'll notice that just because this original is true does not make this one true. Now if we go up here, and we're talking about in my classroom only, this is a true statement. Right? In my classroom only, that's true. And so in my classroom only, is this one true? If the light switch is not up, then the light is not on. That would be true, right? So in this case, again, emphasizing in this classroom, this would also be a true statement. So sometimes the inverse is going to be true, even though the original is true. Sometimes the inverse is not true, even though the original is true. Okay? So you have to realize that sometimes it's true and sometimes it's not. It's like the converse, right? So in other words, it's not necessarily true just because the original is true. Contrapositive. The contrapositive takes the converse of the inverse or the inverse of the converse. Either way, however you want to look at it, it gets you the same place, the contrapositive. Again, you don't have to recopy down the statement if tomorrow's storm drops 10 inches of snow. We already have that in our notes. The contrapositive says we take the converse of the inverse. Or you can think of it as the inverse of the converse. So first of all, what does a converse do? We haven't revisited that yet today. We learned the converse a long time ago. What does a converse mean? What do I do to get the converse from a conditional?
Flip the hypothesis and conclusion.
Yeah, we switch hypothesis and conclusion. So the converse of this statement would say, if we will not have school tomorrow, then the storm drops 10 inches of snow, right? That's what the converse would say. The inverse of this we just wrote said, if tomorrow's storm does not drop 10 inches of snow, then we will have school tomorrow. So now what we need to do is mix those two together. So we're going to take this part and switch it to the beginning and do what to it? We will not have school tomorrow and switch it to beginning. That would just be the converse, right? So if we take the inverse of that, what would it be? We would take out the not. Yeah, so we'll say if we will have school tomorrow, then what? If we move that to the beginning, what goes to the end? Okay, then the storm does not drop 10 inches of snow. Okay? So you have to excuse me, you have to negate both the hypothesis and conclusion and switch places with them to get the contrapositive. Okay? Now let's look at this. We said this original statement was true. Okay? Let's look at what we wrote in the contrapositive. If we will have school tomorrow, then the storm does not drop 10 inches of snow. Okay, do you think that's true or not? Do you think it's possible we have school tomorrow? We will have school tomorrow, but we do drop 10 inches of snow from the storm. Yes or no? Yeah, but not if this was true, right? This statement says if we get 10 inches of snow, then we'll not have school, right? So if that's a true statement, then if we have school tomorrow, then we know the storm did not drop 10 inches of snow. So the reality is that this is also true. Okay? And it's important that you understand that the conditional and its contrapositive are either both true or they're both false. They're either both true or both false. Okay? That's really important. It's not true, that statement wouldn't be true for a converse, it wouldn't be true for the inverse, but with the contrapositive it is true. Either both statements are true or both statements are false. Okay? Oh, I have a typo here, I didn't realize that. is contrapositive are either both true or both false. Please don't leave the words both out. If you take those words out, you get the statement that says a conditional is contrapositive are either true or false. Well, that's true in every scenario. But this is much stronger statement than that. These are saying the two go hand in hand. You can't have the conditional be true and the contrapositive be false. They can't be opposite of each other. They have to have the same truth value. Okay? All right. Equivalent statements, just reminding you, equivalent statements have the same truth value. For example, if 5x minus 7 is equal to 12, then an equivalent statement to that would be 5x is equal to 19. And they have the same truth value. Okay? So what we're saying is a conditional and its contrapositive are equivalent statements. They have the same truth value. Okay? So equivalent statements have the same truth value. Make a note of that. Equivalent statements have the same truth value. So those two equations are equivalent. I use the example of the equations because that's something you already have seen many times, and you've been talked to about how they're equivalent, because we added 7 to both sides, so we get an equivalent statement. Okay? Any questions on that? Equivalent statements have the same truth value. Okay, last concept here. Indirect proofs. There's 3 steps to writing an indirect proof. We start out by stating the assumption that negates what we want to prove. Then we use good math logic to prove the assumption is true until we find a contradiction. Then we conclude that the assumption is false. What we really wanted to prove in the first place is true. So in the indirect proof, we write in a paragraph form. Excuse me. Step 1 says state the assumption that negates what we want to prove. So we want to prove that square root of 8 is not equal to 2.8. Okay? So what would negate this statement? What would negate that statement? The statement says square root of 8 is not equal to 2.8. How do I negate that? Go ahead, Hunter.
Square root of 5.6 is 2.8.
What's that?
I'll let you know when I did it wrong.
We just take this statement right here and write the negation of that. Tell me what the negation of that is. Square root of 8 is not equal to 2.8. The light is on. How do I negate that?
That it is equal to that?
Yeah. Yeah. So I'm going to say, let's assume square root of 8 is equal to 2.8. Okay? So you just make the assumption that negates the statement you want to prove. They said it's not equal to 2.8, so to negate that, we take the not out and make it equal to 2.8. Okay? So now, step 2. Use good math logic to prove your assumption is true. So now we have to pretend we really believe this is a true statement. And we have to use good math logic to prove that. So the question, if I want to get rid of my square root symbol in this equation, how can I rewrite this? What would I do to get rid of my square root symbol? Brandon's like, no, don't look at me. Don't call on me, Miss Mitchell. How do you undo square root? Come on, I know it's Monday, but we gotta get into this. How do you undo square root? If I had square root of x equal to 4, okay, how would I undo that? I said 4, so I write something else.
Multiply it by itself.
What's that?
Multiply by itself.
Or how do you undo square root? You square both sides. Okay? You undo square rooting by squaring both sides. So I'm going to say, let's assume that the square root of 8 is equal to 2.8, then square root of 8 squared will equal 2.8 squared. Right? And when you square a square root, what happens to your square and square root symbol?
Goes away.
They cancel. But 8 is not equal to what? What's 2.8 squared? You'll have my calculators out, and class calculators, but go ahead and use your phone if you need to. What's 2.8 times 2.8? Go ahead and use your phone if you need to. What is 2.8 times 2.8?
Isn't it 5.6?
I don't think so. Sounds like 2.8 times 2.
Oh, yeah. Whoops.
7.84. Does everybody agree with her? Okay. Do you agree that 8 is not equal to 7.84? Okay, so we use good math logic trying to solve until we find a contradiction. We have a contradiction there, don't we? So then we conclude, I think we're on the wrong schedule. Then we conclude that the assumption is false. So we say, therefore, square root of 8 is not equal to 2.8. Okay? Well, hopefully you recognize, hey, there's not much to that. 3 steps. Okay? That's all it takes. You start out by assuming the negation of what you really want to prove, and then you use good logic to prove that statement true. And once that logic produces a contradiction, you state what you really wanted to say. In this case, square root of 8 is not equal to 2.8. Okay? Now, I'm not going to give you a whole bunch of this kind of stuff, indirect proofs. But you need to understand the 3 steps of it. Okay? I could see a test question saying, what are the 3 steps to an indirect proof? So you need to know that. All right? Okay, let's pause for a second. So 1 through 20 all, there's a few in there where they ask you to identify what is, there's like 3 statements and they say which 2 statements are contradictions. Okay? When they ask you that question, you're saying, which 2 things can't be true at the same time? It'd be like me saying, the lights in my classroom are on, the window shades are closed, the lights in my classroom are off. Which can't happen at the same time? The lights are on and the lights are off. Can't be occurring at the same time, right? They're either on or they're off. Doesn't matter where the window shades are, so that's not a contradiction. But it's a contradiction to say the lights are on and the lights are off at the same time. So they're not quite that obvious, the contradictions, but that's the logic you have to use. What can't happen at the same time? Those would be contradictions to each other. Like in this example here, x cannot, I'm sorry, not x, square root of 8 cannot equal 2.8. And at the same time that 8 is equal to 7.84. I mean, you know, see what I'm saying? There's a contradiction there. Can't both be true. All right. So go ahead and work on that. I'll put the answers up to 3. And then if you have questions, you can ask. Okay, I forgot we didn't do anything for 3, so let me clear this up. All right. Now, the homework I would give you for lesson 5.3 is 1 through 16 off. I don't expect all this to be done tomorrow, but work on it. You've got 30 minutes left in class. Get as much done as you can. Tomorrow, then, we will do notes on 5.5. That's the last lesson in this unit. And I'll give you a small assignment there. And then Wednesday, we have a half day, so you'll be able to spend Wednesday and tomorrow and today finishing these 3 lessons, okay? So don't worry about getting it all, taking it home, finishing it all tonight, but just work diligently while we still have class time.